Hey guys, so today I'll be talking about how you can use symmetry to graph polar equations. So there will be 3 tests that you can use to test for symmetry in polar coordinates. The first one allows you to test symmetry with respect to the polar axis or the x-axis. So first you're going to want to replace theta with negative theta, and if after you plug in negative theta, if it is equivalent to the first equation, then there is symmetry to the x-axis or the polar axis. So for the second one, you are able to test symmetry with respect to the line theta equals pi over 2, which is the y-axis. So for this, you're going to be replacing both r and theta with a negative r and a negative theta. And as stated earlier, if it is equivalent to the equation that you began with, then it will be symmetric to the y-axis. So for the third and final test, you'll be testing if there is symmetry with respect to the pole or the origin. So you will be replacing r with negative r, and if the equation is the same from when you started with, then you will have symmetry to the origin. So for my first example, I chose r equals 1 minus cosine theta. And first you're going to want to test for symmetry. So I chose to start with the x-axis, so you plug in a negative theta. And as we learned in chapter 5, with even and odd identities, cosine of negative theta will just equal cosine theta. So that will work, meaning r equals 1 negative cosine theta is the same as the equation you started with, so there is symmetry with the x-axis or polar axis. So next you'll be checking for symmetry with the y-axis. So you plug in negative r equals 1 minus cosine theta, leaving you with negative r equals 1 minus cosine theta, and then you'll multiply by 1 to make the leading coefficient positive. So r equals cosine theta minus 1. So that is not the same equation that you started with, therefore there is no symmetry with the y-axis. So for the third test, you'll be replacing it with replacing r with negative r. So that'll give you negative r equals 1 minus cosine theta, leaving you with r equals cosine theta negative 1. Also, not being the same equation you started with, so there's no symmetry with the origin. So you will have symmetry with only the x-axis. So now we're going to graph that. So pretty much you just plug in coordinates. So I plugged in pi over 6 and pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and pi. You can just plug that straight into your calculator, giving you these outputs. So graphing these can be a little tricky. I apologize for my graph. I tried my best, but I'm not a graphic calculator. So I just plugged in the points 0, 0, then pi over 6, which comes out of 1.3, or 0.13, excuse me, and then pi over 3 equals 0.5, pi over 2 equals 1, and 2 pi over 3 equals 1.5, 5 pi over 6 will come out with 1.87, and then pi will be 2. And as stated earlier, there will be symmetry with the x-axis. So I like to think of this kind of as a parabola. If you were to flip a parabola over the x-axis, you would just move the points on the other side of the axis. It's kind of the same thing with this. You just move the points over to the corresponding lines. So I plugged that in, and it's going to give you like a weird heart shape, but that is the graph for r equals 1 minus cosine theta. Thank you.